Okay. Thank you. Can we focus, please? There's a lot of chatting going on. Can we focus on board? Literal equations, guys. Those are equations that actually don't have numerical answers. All right. So you'll see now when we do the examples, they are equations with multiple variables, but we're not going to be able to solve. We're not going to be able to get like a value for any of them specifically. All right. So I'm just going to write here on the side. Equations with multiple variables. Now in AP we have seen that, all right, the past few times that we've done AP, we have like a 2a plus b equals 6. All right, that actually is also a literal equation. But when we add another equation to it with the same variable, we were able to solve them simultaneously. But for literal equations, we won't actually be able to do that. So I'll show you now. So, thank you. So for x, let me say this is 1. All right, instead of solving for x, they might ask you to, so I'm just going to say slash make x the subject of the formula. So they could use that wording as well. And then the equation is qx is equal to mx plus p. Alright, so do you guys see what I meant when I say it's on multiple variables? Right, so we have 1, 2, 3, 4 different variables in the equation and no numbers. Now when they say I'm going to solve for x, we can't get a value for x, but we can get an expression for x. Alright, we can make x the subject of the formula. I'm just going to circle the x's that I have. Now guys, when you are solving for x in a normal equation, right, one that has numbers, you would get all the x's on the one side and everything else on the other side, right? Does that make sense? We're going to do the same thing here. This mx term, because they wanted to make x the subject, so they wanted to be x equals everything else, right? So I want to get that x term on the side as well. I'm going to say qx minus mx is equal to 2. That would be my first step. Just getting all the x terms on the one side. Now guys, how can I isolate x from them? Yes. I can take out x as a common factor, right? Can you see that? We have an x in both of these terms. Again, I'm just going to circle the x's. That is what we're trying to get on its own. So I'm going to take x out as a common factor. From my first term, I'm going to be left with q and then minus m, and that is equal to p. What must I do now to just have x equals, Daniel? Yes, okay, I'm going to divide by q minus m. So I'm going to have p over q minus m. So there we have solved for x. It's just not a number, right? It's in terms of other variables. But we can't get a numerical answer in an equation that has no numbers. All right. Yeah. So that's what we're going to be doing in this section, basically. All right, they're going to give you formulas or equations with different variables, and they're going to tell you to make one of those variables the subject. Okay, let's do another one. I'm just going to do it for you, and then I'm going to give you some to do on your own. Make R the subject of the formula. Thank you. Well, when they're asking you to solve for x in a normal equation, they're also making it the subject of the question. You're taking in a number together. So you usually just say solve for it. Right, guys, in this case, there are two r's, right? There's an uppercase and a lowercase. They're saying that we must make lowercase r the subject. So that is what we are going to try and isolate. And that is currently in that bracket. Okay, so I first need to get rid of what is outside the bracket. So this pi, right? What am I going to do with pi? Then I have to divide a by pi. All right, so I'm going to have a over pi is equal to capital R squared minus lowercase r. Now guys, here I'm not going to have to factorize, right? Because there aren't multiple terms with the lowercase r, but I am going to have to systematically move everything to the other side. That's basically what we're doing. Next up, I'm going to move this capital R squared. It's going to become minus R squared, right? So this is positive R squared. I need to subtract R squared. So I'm going to have A over 5, minus R squared is equal to negative lowercase r. Now, do you guys think we're going to get rid of that minus first, or are we going to plus minus square root first? Let's get rid of the minus, right? What am I going to do when I get rid of that minus? What am I actually doing? I am dividing by what number is represented by that minus? Negative 1. Hey, so I'm actually going to divide all of these terms by negative 1. So this is going to become negative a over pi. Yes, you can if you want to. And this is going to become plus r squared equals r squared, right? I've divided every single term by negative 1. So guys, I'm just going to do this quickly because I prefer having what I'm calling in the list. I'm just going to swap the whole equation around. I think I've shown you guys before that you can do that, right? And then what I'm also going to do is I'm going to write the positive term first and then the negative term. Okay, so I'm just rearranging things slightly. And I'm actually not changing anything. I'm just writing it in a different way. To see if you agree that these two lines are equal, essentially. Right? I've just literally swapped the equation around. I put my positive term first and then minus a over pi. And now we're going to have to plus or minus square root. Okay, remember what happens when you take a square over? It becomes plus or minus the square root of r squared minus a over pi. It's greater than 2 numbers. Positive 2 and negative. Now guys, if they gave you more context about this formula, right? If we actually look at that formula, what does it look like, the original formula? What do we think that A could stand for? Area, hey, and then we have a pi, and we have a big R and a small r. This has something to do with the circular thing, all right? Cylinder or sphere or whatever. So in the textbook, they have rejected the negative solution because they say, oh, radius, this is radius, and it's obviously positive. But I think they would have to specify that, or it would have to be a formula that you know already. Okay. Can't split up a square root of a small group and only do it on one. All right, so for x over a plus x over b is equal to 1. we basically solve all of these just as a listener. Now guys, again I have two terms with an x in it, right? And we're obviously trying to get the x on its own. We're trying to isolate the x, we want to make x the subject, but this is actually an equation with fractions, right? So we can't like take out an x as a common factor from those fractions here. All right, what would we do when we're solving for x in an equation with fractions? The LCD. Do we see that the LCD in this case is AB? Okay, A and B, the LCD is AB. So I'm going to times that one by AB, I'm going to times that one by AB, and the one, right? You have to multiply every single term by AB, guys, not only the terms that are fractions. That's a common mistake. And guys, if you make that mistake, you get 0 for the whole thing. And I call that a breakdown. So if you are just multiplying these two terms by AB and not the other side of the equation, break down 0 for the whole thing. All right, you don't get into it. So this is very important, please. Okay, once we've done that, we can see that for the first term, the A's are going to cancel out. So we're going to be left with XB or BX. For example, we can get this anyway, too late now. Plus, from the second term, the B's are going to cancel out. So XA or AX. And on the other side, 1 times AB is just AB. Now what? Okay. Now I'm going to factorize, right? I want to get x on its own. I have two x terms, so I'm going to take x out as a common factor. And I'm going to do b plus a, or you can even write a plus b, it's the same thing. And b equals to ab. And now to get x on its own, again, just like in the first example, we have to take ab and divide it by that bracket. So b plus a, or you can write a plus b if you prefer. Okay, any questions, guys? Fine. All right, we are going to do quadratic equations as well today. You have already kind of done some of it in AP. I even taught you the quadratic formula, which the other classes won't know. All right, so the other classes will only learn it in grade 11, but you are allowed to use it in a test or exam. But we're just going to go over how you are supposed to do it. Okay, but it doesn't matter, you'll get 2 marks. Yeah? Yes, yeah. In the AP test, I'm going to give you the formula, but in the core test, you won't get it. Yeah. I'm going to type it on the question. And then telepathically send it to you, Jonathan, personally. Yes, no, you haven't. All right, quadratic equations in one unknown, that means that we're going to be working with just one variable. Right, that's just getting in the textbook. So I'm just going to do a couple of examples. This also came up in your AP cut, so if you've worked through that already, you would have revised this. You actually did all of this last year already. It's nothing new, it's just revision. The only thing here is that you need to be able to do those more difficult trinomials, which you weren't able to factorize last year. This year they can give you those to factorize and then to solve. So that's the only thing that's new. Okay, so x plus 1, x minus 2 equals to 0. Now guys, yeah, lots of people say, oh, I have brackets, I'm going to multiply them out, and then what am I going to get if I multiply these brackets out, if I pull them out? My first term is going to be x squared, right? Do you agree? So this is going to actually give me a quadratic equation if I multiply it out. So lots of people do that. Even my grade 11 did that now in the class 6. They multiply these brackets out, they're like, oh, it's a trinomial. Then they factorize it, and then they get the exact same brackets. Right? Even worse, they factorize it and they get different brackets. That also happens sometimes. All right? It's a common mistake. But if they're giving you the product of two brackets equal to 0, this is an already factorized trinomial, right? So let's write that on the side. Trinomial that has already sorry, trouble my throat this morning. Been factorized. Okay. Now guys, can we remember what we do in this case? We have a product of two things, all right? It could either be an x and a bracket, and the product must equal 0. Yes,
So you can say the bracket is 0 and the other bracket.
yeah, either x plus 1, the first bracket will have to be 0, because that is the first bracket is 0, right? It doesn't actually matter what my second bracket is. 0 multiplied by anything is 0. Okay, so if my first bracket is 0, that will make the equation true. But there's also a possible second solution. If my second bracket is 0, then we're going to have something times 0 again, which is going to be 0. Right, so that is what you always do. When you have a product of more than one thing, it can even be 3. All right, 3 brackets of 3 things equal to 0. All of those brackets, all of those factors, sometimes just an x, will have to be equal to 0. Now from here, let's just move that plus 1 over. It's going to become negative 1. Okay. You have to do that. And as you are allowed to go straight from the question to the two answers, right? You don't have to write this text down. Just write it down now for the first example so that you remember where that comes from. But after a while, I think you'll be able to look at x plus 1 and just think x must be negative 1. And then you'll be able to look at x minus 2 and just think 2x has to be 2 to make this bracket 0, right? So 2 minus 2 is going to be 0. So it's fine if you just go straight to your two answers from it. Okay, number 2, sometimes you are going to get something like x squared equals 2x plus 8. And whether you're going to factorize or use the quadratic formula, you always first have to get it in standard form. All right, standard form is everything on the one side and then equal to 0. Just hold on. So ax squared plus bx plus c equal to 0. Right? For any quadratic equation, you have to do that. You have to get everything on the one side and make it equal to 0. Now, guys, if this is trinomial, it's easy to factorize. Please just factorize it. It's going to take less time than actually using the quadratic formula. All right? I only suggest using the quadratic formula if it's maybe one of those with a different value in front of the x squared, like a 3x squared or something like that, a more difficult one.
When we know
You always have to do this before you can factorize. You can't factorize it. That's what it's on. Yeah, well, that's not going to help you. As soon as you see that it's quadratic equation, so as soon as you see that you have an x squared, then you have to get everything on the one side, which is 0. What I'm saying is, if we take out of 2 of the common factors here, you still won't be able to solve it. It's not going to help you. Okay, how can I factorize that, guys? Factors of 8, the difference between them must be negative 2. X minus 4, x plus 2. That was faster than actually writing out the quadratic formula and typing it all into the calculator. Right, you see what I'm saying? So if it's an easy trinomial, please factorize it. I think most of you are fine with factorizing the more basic trinomial. And even the more difficult ones, you can also do those. Right, so it is up to you. In grade 10, they won't give you trinomials that cannot be factorized. All right. In grade 11 and in 4, remember we did a few quadratic equations where you got like decimals as your answers. Right? Do you remember that? So those ones will only come up in grade 11. Okay, in grade 10, 4, there will always be trinomials that you can factorize in order to solve. Okay, what value will make my first bracket 0 here? What x value? X would have to be 4, right? So 4 minus 4 is going to give me 0. So x is 4 from that first bracket, or from the second bracket, -2. Or guys, if you feel more comfortable, you can write x minus 4 equals 0, or x plus 2 equals 0, and then just move those down to the cross. That's perfectly fine. Okay, let's do another one quickly. 2x minus 1 times x plus 2 equals -2. Now guys, in this case, can I just say the first bracket equal to 0 or the second bracket equal to 0? No, because there's a -2, hey, on the other side. Right? This property where we can say the one bracket equal to 0 or the other bracket equal to 0, you have to have a 0 on that side. Because 0 is the only number that if you multiply anything by 0, anything by that number, it will give you 0. Right? That is why we always pick up a big plus and we say you always have to get everything on the one side and equal to 0. I can't say here 2x minus 1 must be -2. Because if this is -2, then that's going to be something else. And -2 multiplied by anything is not going to give me -2. All right? It has to be a 0 here. So I'm actually going to have to multiply the bracket off first. So 2x squared plus 4x minus x minus 2. Let's also bring this -2 over because we can see that it's a quadratic equation. So we have to get everything on the one side equal to 0. So I'm going to bring this -2 over. It's going to become +2 equal to 0. So I multiplied out and got everything on the one side in one step. Okay, you can do that in 2 steps if you want to. Let's collect like terms. 2x squared plus 3x. And then -2 plus 2 is 0, right? Now guys, lots of people see this and they're like, oh no, now I don't know what to do. This is actually easier than the ones that are trinomials, right? Because you're still going to factorize, but what am I going to do? I got x. I'm going to be left with 2x plus 3 equal to 0. It's actually easier factorization, and lots of people stop there because they're like, oh no, it's not a trinomial, I don't know what to do. All right, it's still a quadratic equation. You still have to factorize. Remember, there are different ways of factorizing, right? We did common factor, you can do common bracket, you can do difference of 2 squares, some are difference of cubes, grouping even possibly, all right? And then also trinomials. So guys, it's not always going to be a trinomial. Yes? Right. Now I again have the product of 2 factors equal to 0. In this case, the first one is just an x, not a bracket. But I'm still going to say, guys, the first factor has to be equal to 0, or the second factor has to be equal to 0, all right? So x must be equal to 0, or 2x plus 3 must be equal to 0. So it doesn't always have to be 2 brackets. Okay, it can be an x and a bracket. Now here, obviously, x equals 0, that's already an answer there. I must make x the subject here. 2x is going to be equal to -3. So x is going to be -3 over 2. Next. Yeah. I just did the work and there was a more complicated one. But yeah, okay, guys. We're doing okay. So basically, remember to look out for all the different types of factorizing. Don't panic and shut down if it's not a trinomial. Okay, and also be a difference of 2 squares. Or like we have here, just a common factor. Okay, I'm gonna give you some, to practice, I'm gonna give you some literal equations and some quadratic equations. So exercise 4.4.
Okay.
Yeah, so all classes are supposed to finish this chapter on Friday, and we have now actually done everything. We just need to still do a note on simultaneous equations, but we've already done it in AP. So we're just gonna do a note. We'll do that on Thursday. And let's do.
But why did they make so much?
Yeah, but it's not during your math lesson. Yeah, it's at the end of the day. So you can have. No, it's in period 6.
Oh, there's a multi.
In period 6. Yes. Yes. Guys, I'm gonna say this one more time. Your Olympiad is going to be in period 6 on Thursday. You have maths in period 2. So you're not writing the Olympiad in the math lesson. You are going to be missing your period 6 lesson. Whatever that is. Okay, I would like you to do number 1. And then number 1 and number. Okay, done. Number 1 and 9. So this for Thursday, okay? Yeah.
And we have like a million. Yeah.
Oh, no.
We have your.
Guys, listen, guys, math is the most important one. Listen.
It's just like, I don't know how to say.
Oh, you can have time now. You're welcome to do this. Okay, number 1, I'm not going to give you many of these because you are kind of doing it in your AP class already. So I'm just going to give you number 1, K. And O. Okay, oh, how's that? That's all. So just 2 quadratic equations. More of the little one because you haven't really done those before. Yes. Yeah. Okay, I can actually put exercise 4.4 on the board because it's all together. That's questions from number 1 at least. Copy that down quickly, then I'll put it up.
I think we can't do it.
That's the 8.
Oh, no.
Okay, guys, there's number 1. And the 9 is at the bottom of the page, so I can't put that up, unfortunately.